Yeah, today we will discuss about the finite automata. What is finite automata? Finite automata are used to recognize the patterns. We're going to recognizing the patterns. It takes a string as an symbol as input and changes its states accordingly. That means at the one state it is going to be reading a input alphabet symbol and moving to the another state. When the desired symbol is found, then the transaction occurs. That means whenever it is going to be reading the input at the time only, it is going to be getting the transaction occurs. At the time of transaction, the automata can either move to the next state or the stay at the same state. Whether it will be moved from the one state to another state, or it may be stably it will be stay at the same state. Finite automata have the two states. One is acceptance or rejected states. When the input string is processed successfully, then we'll call it as accepted or accepted state. The automata reaches to the final state, then it will be called it as accepted state. Otherwise, it is called the rejected state. That means it is not reaching to the final state means it is saying that it is a rejected state. That is, it is going to be having the continuous, it is having the looping. So there is a no end point, so it is going to be rejected state. Working with finite automata. Here we have the magnetic tape. The magnetic tape is divided into the equal squares like this. In that, we are having the input alphabets like 0, 1, 1, 0, 1, 0 has been considered as a input symbols in a magnetic tape. Here we have the finite automata is represented in a square box. That is called the finite controller. In that finite controller, we're having the set of states like Q1, Q2, and so on up to Qn set of states. Whenever we're having the input reading, it moves from one state to another state. We have seen studied in that. So here the finite automata we are having the header. Here we have the header. Header will be indicates to read the input symbol from the magnetic tape. When it moves, when it reads the input 0 at the state of Q naught. So after reading that from the Q naught to, it is moving to the next state, that is 0 to 1. It is going to be moving from left to right. So the now the value is 1, right? So it is moving to the state. So from Q naught to, it is moving to the state Q1. Like that, at the state of Q1, it is going to be reading the input symbol 1. So after reading that, it is moving to the state Q3 or Q2 like that. Okay. Finite automata machine M can be defined as, right. Here after reading the finite automata we have to define the machine. That is what are the things it having. It is a 5 tuple finite automata machine. The 5 tuples are q, sigma, delta, q naught, and f. Q represents the, or q defines the non empty set of states, and summation of sigma gives the alphabets, input alphabet or input symbols. Delta. Delta maps from sigma into q tends to q, or we can say that q into sigma tends to q. Q naught is an initial state and f is an final state. So this is the way we're going to be representing or defining the finite automata FA. Notations for the FA. So while we're going to draw the transition diagram or a finite automata machine, we have to learn the some notations. Here we have the arrow mark. It is called the starting state of the. Here we have the single circle is called the state. Double circle will represents the final state. This is about the finite automata, working of the finite automata, and notations for the finite automata. If you like this class, share and give the comments to encourage me. Thank you.